Hi, let me share my screen. My talk is titled AdBERT, an effective few shot learning framework for aligning tweets to Super Bowl advertisements. My name is Dabarati Das, and I'm the presenter for today. And this research has been done by the University of Minnesota Twin Cities Computer Science and Journalism Department. Watching television while simultaneously using social media has become an ubiquitous phenomenon today. This gives rise to a social TV ecosystem where the viewers watch television content like political debates or social events like Super Bowl and tweet about it on social media. By examining the social media conversation, the content creators on television can gain business insight about their product and how it affects their audience. There has been a lot of research involving the social TV ecosystem, such as investigating the impact of TV on social media conversation and that of factors like celebrity presence on word of mouth. There has also been a lot of work related to capturing engaging moments on television. For example, the fly that landed on Mike Pence during the vice presidential debate, or the very funny Baby Peanut ad during the Super Bowl were both attention grabbing moments that were highly talked about in social media. This implies that there should be some kind of tool to capture these kind of attention grabbing moments, and there are, but here we identify some gaps in the research and target that gap for the positioning of our study. There is a need to model the event and the reaction to the event jointly, and other studies do this separately. Similarly, while other studies are able to capture attention grabbing moments in longer events, what happens in the case of short attention grabbing moments in things like advertisements? People also typically tweet about the advertisement much after watching it, while studies that currently work on this do this using methods that are focusing on it right away. In our study, we focus on these gaps and develop a tool to map the tweets to advertisements while addressing these gaps. Let us consider two tweets made during the Super Bowl 2020 broadcast. Our objective is to figure out which tweet is being talked about. In the first tweet, it explicitly mentions the brand name Google. And it is obvious that this tweet is talking about Google's Loretta advertisement. In the second tweet from the content, it's not that trivial to find the advertisement tweet mapping. In this case, when we watch the Ole advertisement that has the hashtag make space for women, we can infer that this tweet mentions diversity and inclusivity, and it probably refers to the ad by Ole. In our research, we try to make both these direct and indirect mappings from tweets to ads. The main technical challenges of our problem are understanding the advertisement holistically, as a viewer could be responding to the brands or even the creative elements of the advertisement as mentioned in the previous slide. Other than that, advertisements could be about a highly popular or controversial advertisement, such as Donald Trump for president, while some advertisement could be not so popular among the viewers. This leads to an imbalance between the ad classes. Moreover, advertisements during the Super Bowl are only shown during the commercial breaks and are of very short time span. This implies that most of the tweets about the Super Bowl 2020 are game related and only a very small percentage are advertisement related. Therefore, there is a very limited representation of tweets per advertisement class. Our advertisement to tweet mapping model needs two input data sets, the first of which is the advertisement information data set. We create this by using annotators who watch the advertisement and prepare key phrases that describe it best. For example, here we see an advertisement by Audi, which features actress Maisie Williams, who drives the Audi and sings the song Let It Go. We can see then the appropriate keywords annotated for the same in the table. The second input to our model is the tweet information. For this, we took our collected time-relevant Super Bowl tweets, and after some NLP pre-processing steps, we narrowed it down to some candidate ad-related tweets. We manually annotated a random sample of these candidate tweets such that we read every tweet and map it to the advertisement it refers to based on the ad information dataset. Here you can see an example of some mapped tweets. For example, the tweet that says MC Hammer still making money with songs low key. When we watch the Cheetos advertisement, we know that the celebrity featured in it is MC Hammer. So that is the advertisement that it is being mapped to. AdBERT, which is our final contribution, is a few-shot learning framework we developed that maps tweets to advertisements by learning jointly from both the ad information as well as the tweet information. We model this problem as both a binary classification and a semantic relatedness task, and the details of this approach can be found in our paper. Here are some interesting examples that are found by AdBERT. In the first example, AdBERT is efficiently able to use both the ad information, which is the phrase Cool Ranch, and the tweet information, which is Doritos, to give Doritos a higher score than Amazon Alexa, which featured the celebrity Ellen. So here we can see that Doritos is given 0.98 F1 versus Amazon Alexa, which gets a 0.67. The second example is MC Hammer still making money with songs low key? This wouldn't be mapped to any advertisement without the ad information. Here, as only by watching the Cheetos advertisement would we know that MC Hammer is a celebrity which is present in the advertisement. AdBERT has been used in multiple audience engineering pipelines as a key building block. For example, Lu et al. Use AdBERT to map tweets to ads and followed that up with analyzing the mapped user's affective state. Similarly, Kim et al. Used AdBERT to do tweet mapping with advertisements and then examine the map users for evidence of gender-targeted advertising. In a conclusion, we formulate a general tweet ad mapping problem in the domain of social TV, which can be extended to similar systems like presidential debates or vaccination advertisements. We also develop AdBERT, which effectively aligns tweets to the corresponding ads in the Superbowl 2020 social TV ecosystem. We develop two data sets which can be used to further social TV research. One is the ad information dataset, and the second is the tweet ads dataset. Thank you. Thank you for all your time, and questions are welcome.